This lesson is on applications of right triangles. And some of the problems that we're going to do today deal with direction or bearing, as it may be written in the word problem. And that involves two relationship to north, south, east, and west that I'm going to kind of try to describe right here. For example, the bearing south 34 degrees east means if you're looking at the north-south line, and you're focusing on the south, then you go toward the east, which would be in this direction, 34 degrees. So this angle right here would be 34 degrees. The next one, the bearing north 55 degrees west, means again looking at the north-south line but orienting toward the north, then imagining going west of that, 55 degrees. So your angle would be here, and this would be 55 degrees. So again, first look at the north or the south, and then go in the direction east or west that they are giving you, and that will be the angle that you need. For our first example, we are going to deal with this bearing. We have a forest ranger at point A sees a fire directly south. So we'll just say here's point A, and then there's a fire that's directly south of point A. And the second ranger at point B, which is 7.5 miles east of the first ranger, so east of the first ranger, we're going to put point B. And we know that distance to be 7.5 miles. They're going to see that same fire at a bearing of south 27 degrees 23 minutes west, and then we'll have a question, how far is A from the fire? A from the fire will be our X. But we need to work on this bearing here. We're at B. We're first going to look south, and then 23 degrees west. So we're going to open up to the west 23 degrees. So this angle will be 23 degrees. That is obviously not in the triangle. We're going to assume this is 90. This is not inside the triangle. So to get the angle that is inside the triangle, you have to look at the fact that the east-west line and the north-south line are perpendicular, so they add up to 90, which will make this angle next to it complementary to this one. I just realized I've written the wrong thing here, so I need to change that. I was just glancing at it. So it was 27 degrees 23 minutes. So 27 degrees 23 minutes. Alright, so I'm going to use my calculator to get the angle that would be in this top corner just by subtracting from 90. So subtracting from 90 in my calculator, I get this top angle in the triangle to be 62 degrees and 37 minutes. And you can get in that those symbols again in that angle menu that we discussed in an earlier lesson. So now that I have something inside of the triangle, I can look at it as a trig problem. I'm focusing on this angle, the side across from it. Our opposite side is X. Our adjacent side is 7.5. That makes this a tangent problem. So tangent of 62 degrees 37 minutes will equal X over 7.5. And then to solve, I'm going to multiply both sides by 7.5. And when I type that in, I get 14.4, roughly 8, and that will be in miles because our original distances were in miles. And so that is how far that fire is from A. And that concludes this problem. Okay, our second example is also going to deal with bearing. We have a group of Boy Scouts that are on a straight trail headed north 30.6 degrees east, and they found that that led through a briar patch, and they chose to walk east 156 meters and then south, north along that edge back to the trail. So, in other words, let's start out with which direction they were going to begin with. If I just do a little north-south line, focus on the north, 30.6 degrees east would be going toward the right there. So 30.6 degrees. This would be the angle we're talking about. So our path is this skinny one over here, and that's what they're following. But at some point in there, they get on, they hit a briar patch. And instead of going through the briar patch, they decide to go east 156 meters and then north. So that would make a 90-degree angle right there. Now, obviously, I probably need to extend my briar patch here. Then we want to know how much further they walked around the edge than what they would have walked if they had went through. So I'm going to label some things here. This 30.6 degree angle that they were walking at can also translate up here to 30.6. Now again, that's outside of the triangle I need, so I'm going to make it add up to 90 to get the missing angle. So this one here would be 59.4. 59.4 inside of the triangle. And I'm going to need to find both the distance that they walked along the edge and the distance that they would have been through the briar patch to be able to answer the question. So I'm going to call those x and y just so I have something to work with in the equation. So first of all, I'm going to find x. And looking at this triangle, x is my opposite side. I don't have my hypotenuse. I do have my adjacent. Opposite and adjacent go with tangent. So I have tangent of 59.4 is x over 156. And then to solve, I'm going to multiply by 156 and get rid of the fraction. Those are going to cancel. Type that in my calculator. I'm going to get 263.78, and that was in meters. And then I also need to find out what the briar patch part of the path was. So I need to find y, which is my hypotenuse. So I'm going to use adjacent and hypotenuse, which is cosine. So cosine of 59.4 is 156 over y. This time I still need to get rid of a fraction, so I'm going to multiply by y on both sides. And I have y times something, and to get rid of that something I need to divide. So I end up with y is 156 over the cosine of 59.4, which when I type that one in is 306.45. So now I need to actually kind of compare these two things. The actual path that they took along the outside edge, you have 156 plus 263.78. So they actually walked 419.78. Then the briar patch was 306.45. And again, the question is how much farther did they walk? So we'll need to subtract those and get 113.33 meters. And so they walked 113.3 meters more than they would have going through the middle, but of course it was probably the more appealing option here. And so that finishes out this question. Okay, example 3. In the San Gabriel Mountains in California, Lookout Station Running Deer is 18 kilometers due west of the station Lazy Bear. So Running Deer is west of Lazy Bear. The bearing from Running Deer to a fire directly south of Lazy Bear is 38.4. 38.4 east, so south 38.4 east. So the fire, again, is directly south of Lazy Bear, so we'll need to put that in. We know that's a 90-degree angle. Now let's tackle this bearing. So south of Running Deer, so here's our north-south line looking south, then go 38.4 degrees east, so this direction. So if I'm connecting those two, that means that this angle is 38.4 degrees. The one thing I didn't put down, it says that Lookout Station is 18 kilometers due west of the other one, so this is 18. And then the question is, to the nearest tenth of a kilometer. How far is the fire from Running Deer? So that would be this distance here. And then from Lazy Bear, so this distance here. So let's start with just finding x. Before we do that, we're going to have to find an angle that's inside of the triangle, and that again comes back to these two being complementary or adding up to 90 degrees. So if this is 38.4, this has to be 51.6 in order to add up to 90 degrees. Now trying to find x, I have the hypotenuse as my x, and the only labeled side is the adjacent side to this 51.6, which is 18. So adjacent and hypotenuse go with cosine. So cosine 51.6 is 18 over x. Again, I'm going to get rid of the fraction by multiplying by the denominator. And then I have to divide by the cosine of 51.6. So 18 over the cosine of 51.6 ends up to be 28.97. So you could say 28.9 or maybe 29.0 kilometers. Then I'm trying to find where the fire is in relation to Lazy Bear, so that would be y. That is my opposite side. So opposite and adjacent go with tangent. Tangent 51.6 would be y over 18. Multiply both sides by 18. And just type that in your calculator, 18 tangent 51.6. You should be getting 22.71, which would be 22.7 kilometers, since they did ask us to round to the nearest tenth. Okay, this next question is a little bit different because it does ask us what the bearing is. This time we're not finding a distance, we're finding the bearing. So we'll have to be thinking about the angle. So a ship is 15 miles due west of Lighthouse A on the island of Hawaii. So we'll say our ship is here, that will be west of the Lighthouse A. Lighthouse B is 6.2 miles south of Lighthouse A. So B would be down here, 6.2. And again, I forgot to put the 15 for that ship and the lighthouse distance that they gave us. What is the bearing to the nearest tenth of a degree of the ship from Lighthouse B? And so that ship from Lighthouse B, if you're looking from Lighthouse B, we're looking at this angle right here. And then how far is it to the nearest tenth of a mile? So we'll call this x. So I'm first of all going to use tangent to get this angle because I have the opposite and adjacent sides. This would be my 90 degree up here. So I'm going to say tangent of theta is 15 over 6.2. Because I'm missing an angle, that's when I have to use the inverse. So tangent inverse 15 over 6.2. And that gives me 67.5 degrees. Now I have to decide how to put those north, south, east, west stuff on it. So on the north-south line, this angle was coming off of the north. So this would be north 67.5, and then it was in the direction of the west. So west. And so that is how I would answer my bearing. Now, how far the ship is from Lighthouse B can be done without trig because it is a right triangle. I can use Pythagorean theorem. I can say 15 squared plus 6.2 squared will equal x squared. So 15 squared is 225 and 6.2 squared is 38.44. And when you add those together, you're going to get 263.44. And then you'll just take the square root of that. And so square rooting both sides gives me x to be 16.23. And they wanted tenth of a mile, so I probably shouldn't have put the 3, just the 2 miles. And so that answers both questions there. Alright, 5 is an interesting question. We have an architect designing a house. It's going to be 46 feet wide, and it's going to have a roof whose pitch is 11 over 12. Determine the length of the rafters needed for this house. So, we're going to start with a triangle, and we're going to pretend that this is the roof of the house and we're looking at it dead on there. What we're trying to find is the length of the rafters, which are going to be here on the sides. The thing we know is 46 feet wide, so from end to end there is 46 feet. And they gave us this 11-12 pitch, which you're like, what is that? We have some numbers here. 11 and 12 doesn't seem to fit. It's not halfway, because if I divided this, I would have 13 on each, or excuse me, 23 on each side. And so that would be what I would be working with. The 11-12 is actually to give you this angle. We are missing the angle right here in the corner that we're going to need. And so you need to draw yourself a triangle that has that angle, and then we're going to represent the rise as 11, so the vertical part as 11, and the run as 12. So that would be the horizontal part. It's kind of like slope, rise and run. And you're going to use that to get the angle. So you have the two sides that are opposite and adjacent, which is tangent. So tangent theta is 11/12. Then you're missing the angle, so you're going to do tangent inverse of 11/12. And you get theta to be 42.5 degrees. That means that this angle up here in my original problem, what I'm really trying to figure out is 42.5. And so now that really simplifies your problem. If you're looking at this as a 90-degree angle, you can focus on this left triangle here. You have the adjacent and hypotenuse, which goes with cosine. So cosine 42.5 will be 23/x. And again, to get rid of the fraction, I'm going to multiply by the denominator. And then I have to divide by the cosine to get that x by itself. So it'll be 23 divided by the cosine of 42.5. And my x ends up to be 31.2. Excuse me, I was getting ahead of myself there. 31.2 feet. And that is what they were asking for us to the 10th. Okay, example 6. The Golden Gate Bridge has two main towers of equal height that support two main cables. A visitor on a tour boat passing through the San Francisco Bay views the top of one of the towers and estimates the angle of elevation to be 30 degrees. After sailing 670 feet closer, he estimates the angle of elevation to be the same tower to be 50 degrees. Approximate the height of the tower to the nearest foot. Unfortunately, I believe that this is probably the most complicated problem in our notes, but I want you to be able to see it because you'll have some like this in your assignment. So I'm going to say, first of all, that this is our tower, okay? And here is the water that this guy's sailing on, and so that's 90 degrees. And so the first time he looks up, his angle of elevation is 30 degrees. So he's looking up at 30 degrees, and we don't know that height. That's what we're trying to find. He sails 670 feet closer. So he was out here, he comes in closer. That distance that he went was 670 feet. Now when he looks up, he's looking at an angle of 50. Now, having done a bunch of these problems that end up like this, where you have a triangle that's kind of inside of a bigger triangle, you don't quite have enough information unless you find this missing distance here. So even though it's not what we're trying to find, I'm going to give it a variable y, because we're going to need that. Now, some people can look at this and make their two equations. Others have to separate this into two triangles. And what I mean is, like, if you look at the little one where he had the 50, that would just be x, y, 90, and 50. And then if you look at the entire triangle, you have x. This side is not just y, it's y plus 670. And then this angle out here is 30. And so it helps some people to be able to break it down into two triangles because you are going to be making two equations. Let's make an equation off of the first triangle. You have the 50 degrees, the opposite, and the adjacent. So that's a tangent equation. So tangent of 50 will be x over y. Now look at the other triangle. You again have opposite and adjacent with 30 degrees. So tangent of 30 is going to equal x over y plus 670. You'll notice that you have both equations have two variables. Both of them have x and y in them. Anytime you have two equations and two variables, you're going to have to do substitution. Probably back in an Algebra 1 or Math 1 class, you did substitution and elimination with linear functions. You can do substitution with trig. It's just a little bit uglier to look at. The first thing that I always do before I even try to do that, though, is I get rid of the fractions. So I'm going to multiply by y here on both sides, and I'm going to multiply by y plus 670 on both sides here. And when I do that over here, I'm going to put it in parentheses, because if not, you'll get messed up because you do have something that's added. So the y's will cancel out on this one, and I have y tangent 50 is x. On this one, I'm going to put this y plus 670 second. So I have tangent 30 times y plus 670 equals, and again those canceled, x. Now the reason I did that was to get rid of the fractions, but it does actually help us make this a lot easier because now they're both solved for x. So since this one equals x and this one equals x, I can actually just plug one in for the other x and basically end up setting them equal to each other. So if you want to imagine taking this piece right here and plugging it in for that x. So I will have y tangent 50 is tangent 30 times y plus 670. And at this point in this class, yeah, we're worried about getting the right answer, but we don't necessarily care about how many decimal places and, you know, being as completely correct as possible, but we want to be in the ballpark. So at this point, you can actually go ahead and type in the tangent of 50 into your calculator. And if I do that, I'm going to get 1.192. And then the tangent of 30, you can use that square root 3 over 3 from the other day, or you can get the decimal, which would be 0.577. But that helps people generally just figure out how to solve this equation, because you're used to equations that have regular old numbers in them. Even when they're decimals, it's easier for some of you to look at than having these tangents, because you want to do stuff with this that's not legal, but if I give you a decimal, you're fine. So I'm going to distribute over here that 5.77 to this side, so that will give me 5.577 y plus, and then I'm going to multiply it by 670, which would give me 386.59. And then on this side, I just have 1.192 times y. And so I want to get my y's together, so I'm going to subtract the 0.577 from both sides because it has the y and this side has the y. And when I do that, I get 0.615 y equals 386.59, and I'm not sure why that number wants to disappear. And then divide by the 0.615, and I get 628.6. Now the problem is most people like stop here, but that's not answering the problem. You have to make sure, and especially these problems, that you answer what they're asking for. They were asking for the height of the tower, which is x. So now that I have y, I can actually go back to any of these equations up here and plug in. To me, this y tangent 50 is the easiest one, so I'm going to take that y that we just found and plug it in up here. So again, now I know my y value is 628.6. I'm going to say that 628.6 times the tangent of 50 will equal x. And I can just type that straight in my calculator and get 749.13. This was in feet because the guy was measuring in feet in the problem. And so that is the overall answer that I want. Okay, our last example is example 7, and this one is also kind of a double triangle look, but it's not as complicated as 6 was. We have a vertical antenna mounted on top of a 50-foot pole. So I'm going to say, here's our 50-foot pole, and I'm going to say from here up is our antenna. And it says from a point on level ground 75 feet from the base of the pole, so 75 feet, here's our point. The antenna subtends an angle of 10.5 degrees. Find the length of the antenna. So we're trying to find the length of the antenna. This angle thing that they're talking about is looking at the bottom and the top of the antenna and making this angle 10.5 degrees. Now, there's no way for us to know what this bottom angle is just yet. We just know this angle between those two lines, and hopefully you have a little bit straighter drawing than I do. But we can start to find it. I'm going to call it theta, maybe, because we do have this bottom triangle, and we can use that knowledge to get the theta. So I have the opposite side and the adjacent side, again, going to tangent. So tangent theta would be 50 over 75. I'm missing the angle, so I'm going to do theta is tangent inverse 50 over 75. And when I type that in, I get 33.7 degrees. So this angle is 33.7. So now I'm going to look at the whole thing. So I even might want to draw another version of this over here, because I can look at the whole thing as a big triangle. This is still 75. The whole side would be 50 plus x. And the whole angle, when I put it together, is 44.2. So put that whole angle together, we get 44.2. Now I have tangent again. And I can get rid of the fraction by multiplying both sides by 75. So if I type in 75 tangent 44.2, I get 72.9. That's going to equal 50 plus x, and all I have to do is subtract 50. So if I subtract 50 from both sides, I'm going to get 22.9. This one's in feet for my x. And that is the answer to this problem, and that concludes this lesson.